Although this week is supposed to be about hierarchical models, these first two videos are not going to be about hierarchical models. Rather, they're going to cover the material in Krushky, pages 208 to 211. By rights, this material probably should have been covered last week, but I shifted it into this week in order to balance the workload. So there's two main ideas I want to bring forward in this video. One is that last time when we ran first program, we had one parameter. And now I want to think about having two parameters. And secondly, I want to bring forward this idea of derived quantities or derived parameters. So what do we got? What we have is two subjects, Reginald and Tony. And Reginald and Tony have coins from Acme coin manufacturers. And the whole idea about Acme is that they're a novelty coin company, and so that the coins that they produced aren't necessarily going to have a 50% probability in the long run of making heads. And in fact, Reginald has a single coin and Tony has a single coin, and the long run probability of getting heads isn't necessarily the same for Reginald and Tony. So Reginald and Tony have their coins and they toss it. And we record Y, where Y is going to be equal to 1 if it's a head, and Y is going to be equal to 0 if it's a tail. So we've got all these responses, all these zeros and ones. And although it's not explicit, implicitly we can think there's something called I that is row number. So you're going to have 1, 2, 3, 9, 10, all the way down to 15. So that gives us a good idea about what the data are. Now let's think about our model. Here's our model here. And the goal of all this is to try to estimate theta 1, which is the long run probability of getting heads for Reginald's coin, and theta 2, which is the long run Bernoulli binomial probability of getting heads for Tony's coin. So that's what we're all about. And here's our model. And at the bottom we have our dependent variable, y. There's our values of y. And they're indexed by row number. They're indexed by row number. And this bit here is our likelihood function. And so what we're assuming is that the values of y, these ones and zeros, arise from some sort of Bernoulli distribution. And in the case of Reginald, it's going to have a Bernoulli parameter theta 1. And in the case of Tony, it's going to have a Bernoulli parameter theta 2. And so with that in mind, what we see here starts to make sense. Tilde, because we got a distribution, and all this stuff here, this I subject, means that we have to really index our values of y's to reflect not only the row number, but whether we've got Reginald's coin or Tony's coin. And what we have here is just a generalization of this, in that we're saying that the values of y arise from some Bernoulli distribution with a theta that's going to vary with a subject. So that's the likelihood function. And up on top, we have our prior. Now, since we're interested in both Reginald's theta and Tony's theta, we need priors for both. As a consequence, we've got to index these priors according to subject, because we need priors for both. But I'm going to be a bit lazy, and I'm going to say that in both cases, the prior is going to be a rather diffuse prior, a beta 2,2. So that's this bit up here. And then lastly, there's this stuff here, which are our derived quantities or derived parameters. And difference is just going to be the difference between Tony's theta and Reginald's theta. And ratio is just going to be the ratio of Tony's theta over Reginald's theta. Up until now, we've always had tildes here. Now we're seeing something different. We're seeing equal signs because these are just mathematical. There's no sort of distribution involved here. These are just mathematical calculations. So, that's a brief introduction to Reginald and Tony and their coins.